Hi, this is Gunasare, Assistant Professor of Mechanical Engineering at SNS Institutions. Now, we are seeing about introduction to fixed beam. Okay, about our topic, deflection calculation. This is continuity of introduction beam, introduction to fixed beam. Okay. Now, we are seeing deflection calculation in governing equation. Governing equation for beam deflections under load is derived from Elias-Bernoulli beam theory. This theory provides a relationship between the applied load, the beam's geometry and material properties and the result deflections. Okay. Then boundary condition of these equations depend on the beam support. Okay. Example: simply supported cantilever. These conditions specify the deflection and slope at the support, which are used to solve the differential equations. By solving this equation with appropriate boundary conditions, engineer can determine the beam deflection profile and ensuring that it meets design criteria for strength and serviceability. Okay. Now, boundary conditions in structural analysis specify the constraints at the supports of beam, which are essential for solving the governing differential equation for deflection and internal forces. These conditions determine how the beam react to load and help in accurately predicting its behavior. Okay. Types of boundary conditions: simply supported beam at supported deflection 0 at both ends. Here rotations is allowed, but vertical displacement is restricted. Okay. Here fixed beam deflection is 0 at both ends. Okay. So slope is 0 at both ends, meaning no rotations. Okay. Cantilever beam at the fixed end, deflection and slope are 0. Okay. Fixed beam at supported deflection 0 but at both ends. Here at the fixed end, deflection and slope are 0. So bending moment is 0 and shear force is also 0. Okay. These boundary conditions are applied to the governing differential equation to solve the beam's deflection and internal forces. Okay. Ensuring that the beam's design meets safety and performance criteria. Okay. Then also analytical solution. An analytical solution is a structure analysis involved solving the differential equation governing a beam behavior to fix the exact expression for deflections, slope, bending moment and shear force. This method use mathematical techniques to derive precise solution based on the applied loads, material properties and boundary conditions. Example: simply supported beam under uniform load. Okay. Then bending moment diagram. A bending moment diagram, BMD means BMD, graphically represents the bending moment distribution along a beam's length. For example, simply supported beam under a uniform load, the BMD is parabolic. Okay. Here, parabolic says the bending moment varies parabolically due to uniform load. Okay. Here, maximum bending moment occur at midpoint of the beam. Okay. Midpoint of the beam. Here, shear force diagram for fixed beam illustrate the variation of shear force along the beam length, essential for analyzing the beam response to applied loads. In a fixed beam, both ends are restrained preventing rotation and translations. Okay, here calculate maximum shear force, zero shear force, and linear decreases. Okay, calculation reactions determine the vertical reactions at the supported using static equilibrium equations. Okay, track load change as you move along the beam, the shear force change. For example, uniformly distributed UDL cases a linear variations in shear force along the length where the load acts. Point load causes sudden jumps into the shear force diagram corresponding to the load magnitude. Okay, understanding the SFD shear force diagram for fixed beam helps identify regions for maximum shear which are critical for ensuring structural integrity and proper design. Okay. Okay, thank you.